Share screen. And I think we're good. All right, so here's the plan for class today as well as for this video. We are going to talk about some of the more specifics that have to do with dimensioning. That have to do with dimensioning, and we're going to apply those different standards to our green sheet shapes that you should already have saved because we did them not too long ago. If you don't have them, there is a way to get them for the sake of this practice, and you need to do that. I will show you how to do that right now, and this will be in the video if you get lost. So what you need to do is in the folder. How do you get to folders? From here, you go to handout. You may have never used the handout folders before, but if you go there and then go to Holtz and either period 6 or period 1, whichever period you're in, period 6 has the green sheet parts, and this is where you can use each of the part files for the sake of this, because if you only got half of them done when we did grades for the actual parts, you're not going to be able to dimension them. But in order to get them, what you need to do is right click on this folder and do copy, and then go to your My Documents and just right click out in space and do paste. So you copy that entire folder to your My Documents. I think you can probably, you could just right click on My Documents and do paste. The key is you need these files in your My Documents in order for you to change them or reference them and that sort of thing. Because once again, all of the file types, except part files, require access to whichever files they're being used. Like exploded views use assemblies. That file needs to be able to get to the assembly that it's based on, and that assembly needs to be able to get to the parts that it's based on. And same thing with drawing files and so on. So they all need to be saved sort of in the same place. That thing that I just showed you about copying and pasting is only if you don't have the green sheet parts already built. So what are we going to do? Well, we'll go through and we're going to make a single drawing file with several sheets, and we'll go through and fly through each of the green sheet parts and talk about how to dimension them. This is the first year that we're not doing any form of paper dimensioning, which is, I'm sure if you knew what we used to do, we'll be very excited. I think there is value in doing actual sketching on graph paper and using your straight edge and pencil. You learn a lot about it, but it's really tedious, and it's unlikely that you, even if you go into drafting, design, engineering, will ever do anything on paper. So its value is diminishing. But it's still good to know about sort of the actual what parts are what, okay? The extension line are the thin lines that stick out beyond. The dimension arrows are, okay, so the extension line are the thin lines that stick out past. The dimension lines are the actual arrows that are split by the value, okay, with arrowheads sticking out and that sort of thing. All this is done for you in your drawing file when you go to annotate and click on dimension and put the dimensions on there. So that's good. And yeah, it is, like I said, it's a little unfortunate that you're missing out on some of the experience of doing it on paper, but we'll just go through this pretty quick. So from the spreadsheet, the link to a folder called Dimensioning Docs has these guidelines and standards. It also has the green sheet, which you don't really need for dimensioning as long as you have the actual parts. And is this our hierarchy of sins type of thing? All right, so we're going to be referencing this document as we go through our different multi-views of the green sheet parts. And I think we went over this before when we talked about the dimensioning of the puzzle cube pieces, where you put the actual dimensions and not having things overlap, not over dimensioning. And we're going to do stack dimensioning instead of chain dimensioning, which is everything is being dimensioned to one direction as opposed to from one extension line to the next. It looks a little cleaner, plus it prevents redundant dimensioning. Not having lines crossed, not having dimensions on the view itself. The view is the one individual picture. There are 4 views on this page: front view, top view, right view, and a top right front isometric, just for terminology. Not having extension lines cross. A lot of these, like this isn't even one of our rules because there's no way you would accidentally do this. The rules are more like to prevent you from having the extension lines cross over. Not always possible, especially if you have something going on in the inside. But we'll go through these. There aren't any curved surfaces, I don't think, on the front side of the green sheet. So we'll talk about the differences between diameters and radii, when to use those. But it does, Inventor does most of that for you. So again, that's both good and bad. What you're missing out on versus what is just sort of handled. But either way, let's go ahead and get started. So we're going to have a new drawing file. And once that comes up, we're going to have one drawing file for the numbers and one for the letters. Maybe we'll have one for numbers 1 through 10 and another one. So it's not too many sheets per drawing file, just because it would get, if we did all 32 of them on the same, that's a lot of sheets. So we are just going to go through the different part files. And the first one, part A. So you're going to do base view, and we did this before with Puzzle Cube, and find where am I? You can't use the ones, you can't from here, you can't directly open the ones from the handout folder. You have to copy that folder, again, only if you are if you don't already have those. Puzzle Cube, FOT, where is it? I had it before. Give me a second. Green sheet parts. There we go. No. Okay. The other thing is you need to be sure that when you're searching for your file, you're searching for all Inventor files or whatever you're looking for, because I have it here searching for assembly and there are no assembly files in there. Because that's the last file type I was looking for. But here, we're going to go ahead and start with part A. And these aren't really in order of difficulty, just like the way that we didn't necessarily make them in order of alphabetical order. We sort of went through them kind of in difficulty order, but just to have a nice, neat and tidy drawing file with 12 different sheets on it, we'll just do these in order. So we'll do part A first. We hit open and it thinks this is the best front. And part of the reason it thinks this is the best front is that when we made it, this is the face that we chose as front, you know, in that little universe. And that's fine. Okay, choosing the best front is about choosing the one view that gives the most information. Okay, this obviously is missing out on a lot of information. You can't, from the front view, you can't see all these notches, but the top right is not one of the options. This is an option. This is kind of an option. I mean, it's another one. It's fine. This one doesn't give very much information. I think if you're talking about the overall shape idea of this drawing, I would say this is the front. You have a question? This is part A of the lettered ones. And so this is going to be our front view. We're going to put it down here in the bottom left. So we have room for 4 different views. And in this case, 1-to-1 scale is okay, but we could probably make it a little better. Is 1.5 going to be too big? I think it might be too big. Let's see, 1 1/4. You don't, well, at least for this series of drawings, we're not going to have to make that tough choice on the best scale every time because all of the part files are roughly the same size. So we're going to be somewhere in the 1 to 1 1/4 scale for every part. And so we'll put it down here in a bottom left sort of quadrant area and hit OK. And I think there's a way to change it so that after you hit base, it automatically selects projected, but it doesn't anymore. But either way, you're going to click on projected and choose the view you want to project, which is the only one we have. So you're going to click on that, move the mouse up, okay, put it somewhere in here, click. Notice it doesn't make the actual drawing. It just gives you a dotted line. Okay, that's fine. Okay, we want the right view somewhere over here. If you're anywhere close, it locks it in to lined up. We want it over here for the right side view, click. And our standard will be to have an isometric view, a top right, top front right corner view up here, click, and then right click and create, and it will make those views. Okay, obviously we're going to need to rearrange them. In order to move them, you need to put your cursor sort of where you get the red marching ants and move them, sort of space them so that it's comfortable. This is probably pretty good. You know what? I'm starting to regret that 1 1/4. I think let's switch it back to 1-to-1. Okay, the way you're going to do that is right click on the front view, go to edit view, and where scale was, we're going to type 1 and hit OK, and it will update everything. It doesn't automatically change that setting for our isometric view, but we should anyway. And that's just a simple mistake. Not a big issue. Okay, at this point, let's just go ahead and save your drawing file. It's not done. It's not even nearly done, but save it and call it something that makes sense and put it in the same place, whatever folder your green sheet part files are saved in, put it there. So we'll call it green sheet parts 20. I mean, I guess you should probably call it green sheet parts or green sheet letters because we're going to do a different file, an entirely different file for it. Letters, I'm going to put the period in it. You don't need to do P6, P1 there, just screen sheet letters is good. And even though you're in the folder, although most of you probably just have it all the way out in your My Documents, even though you're in that folder, you might not be able to see the part files. And that's because as you're saving it, it's only showing you the drawing files. But you do want to save it as a drawing file. And hit save. And if this comes up, do yes to all. Anytime this, I can't think of another example when you would hit no, but yes to all and then okay. And it will sort of line up the different versions of whatever you're working on. All right, so now we need to do some dimensioning. You'll notice that if you use your mouse wheel up is zoom out, mouse wheel down is zoom in, which is actually the opposite of Google Maps, I think. So just get used to it. There's also press mouse wheel, which I think is probably called mouse 3. Anyway, it gives you the grip hand, but you can move around just by using the zoom. And you may not even need to do that, but it does help when we're need to click on very specific spots. All right, so our general rule, and it should be here. Our general rule is start on the left and work to the right. Every time something changes, take another dimension, and then check to see if that dimension could be better somewhere else. Okay, just stick with me for this one. Okay, working left to right. Okay, all of our dimensions are going to be stacked against the left edge. Okay, so we need to do, well, just in general, we're going to do width left to right, height down to up, and then depth, which is this direction, can either be on the top view or the right side view, because those are the only views that show depth. But the concept of every time something happens means, well, we can go to annotate and do some dimensions. You have to be, well, these are pretty simple, so it's kind of hard to click in the wrong place, but the dimension we want is the length of this line, and it comes in pretty small, but you need to think about things as really the distance between the 2 points, as in the distance between here, and then click. Sort of that 3-click form of dimensioning, first click, second click, and then click to set it. But starting from the left side, the only thing that happens, or rather the first thing that happens, is the distance to this face right here. Okay, remember we're going left to right. The first thing that happens is where this face, where this edge turns into this edge. Okay, going left to right. The next thing that happens is this notch right here. Okay, it's the distance, it's the location of this sort of inner part. And we actually, in our very second dimension, we have a pretty tough dilemma. There's 2 places it could go. It could go from here to here, or it could go from here to here. Okay, both of those, they're not just the same number. And I wish I could get a better zoom on things. They aren't just the same number, they're literally the same dimension. They are dimensioning the same thing. The problem is both of these break at least one rule. And the rule that, okay, this one is dimensioning to a hidden line, and this one is dimensioning on top of or inside the view. Oh, no, that's not dimensioning on top of the view. That's extension lines crossing into the view. Now, what does that mean? I know it feels like a lot all at once. sometimes you do need to have your extension line cross into the view, but you would never have your extension on top of the view. Okay. And dimensioning, having your extension line onto the view is not ideal, but there's no way to, I mean, I guess technically you could put it here because locating this edge from the left side is the same as locating it from the right side. Not both places, but either way, dimensioning this notch on the top view is better than on the front view because a hidden line doesn't tell you what you're dimensioning to. On this front view, you know something happens here at this hidden line, but you don't know what it is. On the top view, you can see this is where the notch progresses. So it's definitely better on the top view. And we're going to get rid of this one. And if you think this is feeling complicated, I get it. My desire to put this in, all the sheets we're going to do in alphabetical order has its consequences. Either way, okay, then we go back to the left side, and the only other thing that happens going to the right is the total width. There, we did width, left to right. Every time something happens, take a dimension. I realize you probably can't see the actual numbers from where you're sitting, but it would show up on a printout, and that's what we're going for. All right, so next is height. Every time something happens, take a dimension, starting at the bottom, going up. There's only 3 things that happen going up ways. Okay, the first thing that happens is the distance from the bottom to this ledge right here. Okay, the next thing that happens is the height of this ledge, which we're given the same dilemma of from before, where we could put it here or here. This one, not only this one goes to a hidden line, it also crosses extension lines. So we're definitely going to put that dimension on the right side view. And then the only other dimension is total height. But if we put it on the front view, we're crossing these extension lines. And if we put it on the right side view, we're golden. Okay, then the only other direction, although I suppose technically it's dimension, we did our width dimensions, we did our height dimensions. Now we need to do our depth dimensions. Okay, depth dimensions are done. We're going to dimension them front to back. Okay, which we can put either on the top view, okay, going this way. Okay, like this and that, or on the top view doing the same thing, going front to back. And even though on the page this is going left to right, it's really talking about going front to back, our depth direction. And you can put them either place, it's fine. Okay, but still we're going to start at the front, which this is the front on this view, this is the front when you're looking from here, and every time something happens, take a dimension. Okay, that's the first thing that happens. Oh, no, it's not actually. The first thing that happens going front to back is the distance from the front face to where this notch happens. The second thing going front to back is where this notch happens. The third is this notch, and the fourth is that notch, and then we need a total depth. So we actually need 5 dimensions for depth, which is rare. Usually most of the dimensions are going to be on the front view, which is usually what makes it the front view. Either way, front to back, the first thing that happens is this. That is not a good place to do it. Let's see if we can put it over here, and we can. So that's what we want. The next thing that happens front to back is this one. That looks good. Third thing going front to back is this one. That's good. Fourth thing is that one, but that crosses over, same issue. So we're going to put it here and get rid of this one. And The only other depth dimension is everything, total depth. So we'll put it there. And so you can see what we've got going on here. At this point, you may just be blindly copying what I'm demonstrating, and that's fine. You will get to it eventually, or get where you need to be eventually. Okay, and that's it for dimensioning. One of the ways you can double check is if you look at the actual part, do you have enough to make this part file? Is there enough here? Well, what was the process we made? Well, we started with a big chunk. Okay, so we needed to have total height, total width, total depth, which we started with total height, total width, and extruded at total depth. Do we have? We have total width, total height, total depth. Good. Then what did we do? The next thing we did was cut away this chunk right here. So we needed the location of this bottom ledge and this left edge, which on the drawing, we just did the alternate, the distance from there and the distance from there. Fine. And the next thing we did was this cutout here. So we needed how far in this happened. Okay, this distance is just we did from here to here, and then the location of this we did from the other side, but we have these 3 dimensions on there. The distance from the front, that 2-inch distance, this was the 2-inch one, which is really just the difference between here and here. And the location of this line is this, but we did it from here, and that's fine. And then the same thing for the last extrusion, the 3 dimensions needed for that we have here. Okay. Again, yes, I know this is a lot to start, but we will do our best. All right. So if you have your dimensions like that, you are good for part A. Go back to place fuse and make a new sheet. Okay, you can see there, now we're on sheet 2. Let's go ahead and just rename. If you go right click, edit sheet, you can change the name to, how about just capital letter A? And how about we rename, or right click at the second sheet, call it B. And there we go. All right, so we'll do B together, and I think that'll probably be it for today. Maybe I'll set you up for C and see if you can, what you come up with for that. But the key is just, it's the process, the step-by-step, left to right. Every time something happens, take a dimension, see if it could be somewhere else. All right, so we need to bring in letter B. That's another complicated one. I really want to get to letter C. Let's just go ahead and build the multi-view for this, just to make sure we keep it where it is. And I'm starting to regret not doing this on paper first, because it's so, there's just a lot going on all at once. All right, well, let's just get through it. Let's just do this one next. Okay, so we are on the second sheet in our set of sheets. And actually, this one isn't too terrible, because on the front view, there's a lot going on, but the right side view and top view there's only one thing that you would dimension there, and that's total height and total depth are the only things that would go on either one of those views. Okay. But we'll get to that in a second. I just want you to stick with the method of starting on the left. Every time something happens, take a dimension. So starting on the left, the first thing that happens is this notch right here. The problem is that we're crossing over. So this one actually is a rare case where the best place to put it would be outside of the views. Okay, you'll see as we go. I'm actually going to shrink this to get a few more pixels for us. Okay, you'll see as we go, the majority of our dimensions are going to be here and here. The width dimensions will go in here, either connecting to the top view or the front view. The height dimensions will go here, either connecting to the front view or the right side view, and the depth dimensions will go somewhere in this region. We aren't going to dimension outside of the views very much unless it's the best option. All right, so in order to find the location of this notch, we could put it here. Well, the first bad option is right there. Lines are crossing over. Extension lines are crossing onto the view, which isn't terrible, but it's not ideal. On the top view, we'd have to dimension to the hidden line. Also not good. So our best option is actually this one outside of adjacent views. Let me make sure that's in our order of, yeah, not between adjacent views is less bad compared to extension lines on view, which is less bad than dimensioning to hidden lines. It's all about, the overall goal is always about avoiding confusion and making things more clear. All right, so let's go back. Left side, the next thing that happens is this notch. So that's a nice clean place to put it. The next thing that happens going left to right is this other notch, or notch, whatever, where a face changes. The next thing that happens is that notch, which offers the same issue as before. This is the place where we're building our stack of dimensions, but we have that issue with the line crossing onto our sacred ground of the view. So that's not ideal. If we put it on the top view, it would be going to a hidden line, also not ideal. So we will end up putting it down here outside of adjacent views. Okay, so we'll get rid of these other ones. And the only other dimension that we have going on is total width. That's it. All right, so let's do some heights. Starting at the bottom, the first thing that happens is the height of this sort of undercarriage part. This isn't ideal, but on the other side, it's going to a hidden line. Not as good. You could slide it in here, but I don't know. It's starting to get kind of crowded because it's actually inside of there. So I don't know. Either one of those is fine. Then from here to here is the height of this first ledge. Okay, if we had it on the right side view, it's not going to the contour, meaning when we put this here, you can see that this is pointing to where this vertical face turns into a horizontal face. On the right side view, you can't tell what that's dimensioning to. So we're going to put it there. And the only other height dimension is total height from the ground up, which could go there, except for crossing extension lines. So we're going to put it on the right side view and get rid of the other one. Okay, so there are heights, and there's only one depth dimension, and it's total depth. And you can put it on the top view or on the right side view, but not both places. Okay, having both places is redundant. So we're not going to have both places. All right. So that is where we're going to end the first video for today. So we're not too overwhelming. Make sure you do save it and yes to all and hit OK. And we'll pick it up with part C next time.